Hello and welcome to the course on C Programming Learn to Code series. This is the 14th lecture of Unit 2, and in this lecture we will discuss integer data type. We also introduce a new keyword which is the part of C99 standard, that is your long. So let's begin. So let us first understand what do you mean by integer. A integer is a whole number that is represented with no fractional components. Like for an example, 45, 765, 56, these are the 56 means minus 56. So all the positive numbers and negative numbers can also included in integers. Which numbers are not included inside the integer? So I have given a list over here like 8.675, root over of 2. So all these numbers are not included in integers. Now suppose assume that you are solving a problem and in that problem you require to store these integer numbers. Now to store these integer numbers you need to allocate some space. So what amount of space you are going to allocate? After allocating the space, what should be the name of that allocated space? So all these things has to be represented by your C program. Means there should be a solution in C programming to represent all these numbers. That's why C program or C compiler represents this using a keyword that is called int. So let us discuss about that. So now we are going into the concept of integers in C. So basically integers in C, or whenever I want to store an integer for solving any problem and we want to write a program to solve that particular problem, then that integer value need to be stored inside the memory. That's why C programming provides us a keyword that is called int to do that. So how to use that int, or that is how to declare that, how to use that int to declare a variable? This is declare something like this. So the syntax of writing or declaring a variable will be, we have to first specify the data type. In our case the data type will be int, okay, and then we have to specify the variable name. So what is the rule of declaring a variable name? That has already been taught to you in previous lectures in the C token part. So it is better you should go and watch that video so that it will be easier to understand this lecture too. Anyway, so if you want to declare a variable, then you need to first write the data type, then you have to type the variable name, and variable name is a user defined name. User have to decide which name, what name he or she want to give. Okay, so that means I have to use the data type here as integer. And how to declare it? So the declaration is something like this. I have used two declarations. In the first declaration I have used to declare a single variable, and in the second declaration I have shown you how to declare multiple variables. Now let us first discuss the single variable declaration. In the single variable declaration, what you will do, you will write int over here. Int represents the keyword, that means int abg. What do you mean by abg? Abg stands for average. So I have given this name abg as the variable name. So when the compiler see this line, that is int abg in my program, the compiler understand that the user wanted to create a memory space and name that memory space as abg, where the user wanted to store integer numbers. So what the compiler will do by seeing this particular line, the compiler will allocate the required amount of memory inside the memory block and give the name as give the name as abg. And what type of data this abg will store? It will store integer type of data. So what is integer? That we have already discussed. Now come to the discussion of multiple variable declaration. In this case I am showing you how to declare multiple variables. There will be two ways to declare a multiple variables: single variable in one line or multiple variable in one line. Okay, so if you want to declare multiple variable like int a, then again int b, then again int avg, then at last int total. So this is also possible. So you are declaring multiple variable, but in a single line you are declaring one variable. Okay, but it is better if without writing this 4 line, you can declare it in a single line also by using comma operators. So here you can see these are the comma operators we are using. So how to declare? I will declare int a, then comma b, then comma avg, then comma total. Then I have to put a semicolon over here. Okay, by this, if I declare the variables like this, so what the compiler will understand from this? The compiler will understand that he has to allocate, or the compiler has to allocate 4 different spaces, and each space is given with different name like a, b, average and total, and every space that has been allocated will store integer numbers. So that means inside the memory, the compiler will allocate a space for a, another space for b, another space for average, and the last space for total. And all these spaces allocated by the compiler will store integer value. Okay, so this is how the declaration of integer variable are taking place. Now let us understand, after we declare the line something like this, int average, so the compiler will decide how much byte it should allocate, is not it? So the question is, how much space the compiler will allocate to store an integer number. So let us understand that one. So particularly saying that, in general, I would like to tell you that it is depending upon the compiler you are using. We know that there are several compilers developed by different companies, and every compiler is different from other compiler, and installing a compiler to a machine depend on different type of operating system we are using. Like for our case, we are using an Windows operating system, and we have installed MinGW compiler, okay, which is a GNU compiler, MinGW compiler, which is a GNU compiler for Windows. But if you are using, you can use Turbo C++ compiler. So that Turbo C++ compiler also can be installed on Windows machine. So if you are using a Linux machine, then you might not require any compiler, because GCC compiler is already installed in the Linux machine. So according to the installation of the compiler, it depends how many bit or how many byte the compiler will allocate in the space. So I will consider two cases, where one case, like your Turbo C++ case, the compiler will allocate 2 byte of space, and for other cases like MinGW and Linux GCC compiler, so everyone allocates 4 byte of space for storing integer numbers. So let us understand how it is done. Let's say this is your memory segment, which each box over here represents a 8-bit block. Okay, so if you are using your MinGW compiler, okay, so if you are using a MinGW compiler and you have declared int avg, then what will happen? It will take 4 byte. So in MinGW compiler, or you can see a GCC compiler, the integer size is 4 byte. So 4 byte means your 32 bits, right? So it will allocate 4 bytes, like this is 8-bit is 1 byte, 1, 2, 3 and 4. So 4 byte will be allocated to store an integer. Now what is the name of this 4 byte? The name is avg, because I have declared int avg. So by seeing this line, if I am using a MinGW compiler or a GCC compiler, the compiler will directly so the compiler will directly allocate 4 byte of space in the memory segment, in the memory, and give the name as avg. But if you are using a Turbo C or Turbo C++ compiler, then what will happen? So if this is the memory segment and each block is 8-bit block, then Turbo C compiler takes 2 byte. So 2 byte means your 16-bit, and the 16-bit name will be the average. avg will be the average of that 16-bit location. Okay, now if you will write after this line, after you are writing int, first of all you write int avg, then suppose you write avg is equal to 375. So that means you want to store the 375 in the allocated space. So what will happen? So this 375 will be stored something like this, 375. Okay, sorry, 375. So it will be stored something like this. So in case of a Turbo C compiler, it will be 375. That means the total 2 byte will be used to store this number. Similarly, for this case, the total 4 byte will be used to store this particular number. Okay. Now, let us understand what is the range. That means if the allocation is something like this, 4 byte or 2 byte, then what should be the range of number that can be stored inside this particular allocated space? So to find out the range, we need to recall the concept that is taught to you in 2's complement representation in the last lecture itself. So never forget to watch the previous video, because the previous video is quite important to understand the range of number provided, or the range of number, how the range of number is calculated for integer data type or any data type also. So you have to read the previous lecture. You must watch that previous lecture so that you can understand your 2's complement representation for the positive number also, for negative number also. And there we have discussed if the number of bit is given, means number of bit is given to store some value, then what should be the range of numbers that can be represented in that n bit space. So the range is defined as the formula minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. So where n is what? N is the number of bit allocated. So here if you see in this particular case for GCC compiler, so the integer size will be 4 byte, so that means 32 bit. So 32 bit means what? 32 bit means n is equal to 32 here. Similarly, if you are using a Turbo C or Turbo C++ environment, then here you are allocating 2 byte. So 2 byte means your 16 bit. So here n will be 16 bit. Okay. Now see the range, how to find out the range. So for our case, for our GCC compiler, means for our case we are using a MinGW compiler. MinGW is nothing but the GCC compiler for Windows. So for our case the integer size will be 4 byte. That's why the range of number that can be represented with 4 byte will be minus 2 to the power 32 minus 1 to plus 2 to the power 32 minus 1 minus 1. So this is 2 to the power 31. So this part will be 2 to the power 31. So 2 to the power 31 will be this much value. You just check, use your calculator and check it. So similarly 2 to the power 31 minus 1, which is this value. So we can represent the numbers from minus this much value to this much value. Now if you are using a Turbo C compiler or Turbo C++ compiler, the range will be, so you are using 16 bits, so the formula will be 2 to the power 16 minus 1 to your plus 2 to the power 16 minus 1 minus 1. So what is the range? It will be minus 2 to the power 15 to plus 2 to the power 15 minus 1, which is nothing but 32768 minus 32768 to plus 32767. So you just check it by using your calculator. This is the range of number that can be represented with Turbo C compiler. Okay. So now that we understand what is the range, what is the integer variable, now let us modify the integer. Means this is not only the integer keyword is given for C compiler, there are several other keywords are also involved which will do the same thing for allocation of integer numbers. So let us discuss that one. So there are 4 different type modifiers has been provided by your C programming language. So what are the type modifiers? That is called short, long, signed and unsigned. So for short we are using short keyword, for long we are using long keyword, for signed we are using signed keyword, and for unsigned we are using unsigned keyword. Okay, so whenever there is a keyword, the keyword must be written in small case letter, as I have already told you. So now let us see how the keywords, these keywords are used along with your integer keyword to modify the allocation size and the range of numbers one by one. So let us first understand short and long. So in case of short and long, we know that for integer assume that we are using a GCC compiler. In our case, this is MinGW. Okay, in our case, this is MinGW. Suppose we are using a GCC compiler. So if you are using int keyword to declare a variable, then how much byte it will allocate? It will allocate 4 byte. Okay, but if you use short int, so short keyword you will use along with integer, that means you will declare something like this, short int abg, then what will happen? This 4 byte allocation will be not there. Means if I'll write something like this, short int abg, then the compiler understand that the abg does not require to be allocated with 4 byte. Okay, so what he will do is the size get reduced by half. That means without allocating 4 byte, this is 1 byte, 2 byte, 3 byte, 4 byte, without allocating 4 byte for ABG, what the compiler will do, he will allocate only 2 byte and give the name as ABG. Okay, so this is the use of short int. Similarly, if we are going to use the long keyword and we will declare long int abg, then what will happen? The concept is size must be increased by double, but it is not happening in this particular GCC compiler. What will happen here? It also take the same thing, that is your 4 byte. Okay, so it will allocate the 4 byte of in storage location for storing the values. Okay, if you are using a GCC compiler for our case. But now let us think about the Turbo C++ compiler. So if you are using a Turbo C++ compiler or Turbo C compiler, what will happen? Integer takes, actually only integer takes how much byte? It will take 2 byte. Okay, integer take 2 byte, and when you write short int abg, so what will happen in case of Turbo C++? Remember the term, we are using Turbo C++ compiler. Then for that case only I am telling you. So if you are using Turbo C++ compiler, integer takes 2 byte, not 4 byte, as I have already discussed. Now if you will use short int, then the size is not reduced. What will happen? It will also take the same 2 byte to store the data in the average variable. But whenever you use long int average for Turbo C++, then what will happen? The size of the average variable will be increased to 4 byte. Okay, so that means for GCC compiler, short int will reduce the value to 2 byte from 4 byte, but does not increase the value whenever we are using long int. But for Turbo C++ compiler, the 2 byte integer will be increased to 4 byte if we will use the long keyword, and it is not decreased even if we are using short keyword. Okay, so this is how the short and long can be associated with your int keyword. Now the next two keyword will be signed and unsigned. Signed means the concept of signed represents that we can use the same space. Suppose space is 4 byte is allocated for integer, then for in the same space we will represent positive numbers as well as negative numbers. Okay, then what is the range? And if we will use the keyword unsigned, then the entire space, entire 4 byte will be used for storing only positive numbers but not the negative numbers. That is the that is the concept behind signed and unsigned. So let us understand it. If you recall, if I'll declare int average for our case for GCC for Turbo C++ compiler, let us say for Turbo C++ compiler, if I'll declare int average, then the allocated byte will be 2 byte. Okay, so 2 byte means 16 bit. So the range will be -3 to 768 to +3 to 767, that we have already discussed. And if you write signed int like this, signed int average, then the concept does not change anything. That means int average and writing signed int average is by default same to each other. That means they will also take 2 byte and 16 bit of information, and the range will be obviously similar. But if you are using unsigned int, what will happen? If we use unsigned int, then automatically the allocation size will be 2 byte, but the range will increase from 0 to 65,535. So how it will be? So you can see, understand this. Suppose I am declaring int average or signed int average, then our range is something like this. The middle position will be 0, this side will be plus 32767, and the negative side will be minus 32768. This is the range. Now if you see, the space is same, that is 2 byte, 2 byte, 2 byte, 2 byte will be allocated due to this int. Okay, so 2 byte will be allocated. That means whenever we are using unsigned int means we will not use this part. That means there will be no negative number. So if there is no negative number, then the entire range will be for positive numbers. So what will happen? The range will be increased. So that means the left side will be represented with 0 and the right side will be represented with the addition of these two values. So addition of two value will be 65,535. If you add these two value, you will get 65,535. That means if you declare unsigned int average, then the compiler will allocate a memory location AVG, which is of 2 byte, and it can store the numbers from 0 to 65,535. Okay, but if you are using only signed int AVG or int AVG, then the allocated space by the compiler obviously having the same name AVG, but it can store the numbers from minus 32768 to plus 367,767, but it cannot store beyond this value or lesser this value. Okay, so that is the concept, right? So this is all about your signed and unsigned int for Turbo C++ compiler. Now for our case, where we are using the GCC compiler, that is your MinGW compiler. So for this case, we know that int average will take 4 byte. Okay, 4 byte means 32 bit. So that's why the range will be something like this. So how to find out the range, I have already told you. So similarly, if we will use signed int average, then also the things are similar, that is 4 byte 32 bit, and the range will be same. But when we use unsigned int, obviously the range will be increased. Why the range will be increased? Even if the 4 byte space will be allocated, so in this 4 byte initially you are using positive number as well as negative number, but for this case if you are declaring the average variable as unsigned, then the same location will be used to store only positive numbers. So the range will be from 0 to this value. Okay, this much of value can be directly represented. So how did I get this number? It will be I will get this number by adding these two value, this value and this value, and the range will be obviously 0 because it is unsigned. That means negative number should not be stored in this average variable. Got it? So this is for GCC MinGW compiler. Okay, now let us combine everything. So we talked about the four things. We talked about int, we talked about signed int, unsigned int, okay, and we also talked about short and long. Now we can combine everything like this. Suppose I can declare signed short int average. So let us say we are using a GCC compiler. So what will be the size of this particular variable? Means this particular average, how much byte will be allocated. This is signed, means we can use positive and negative number. Short int, short means that is 2 byte. So this, for this particular case, that will be the allocated space will be 2 byte, that will be 16 bit. Okay, so 16 bit means the range will be this is signed bit, so the range will be minus 32768 to plus 32767. Okay, for short int. But if it is a signed long int, then if it is a long int, signed means we can use positive number as well as negative number. That means we can represent positive number as well as negative number. Long means that will be 4 byte. So we will use 4 byte integer. So that means 32 bit. So the range will be something like this. The range will be this one. Okay. So I should not write all these numbers over there. So the range will be something like this. Okay. Now the next part is unsigned sort int. Unsigned sort int means, unsigned means we will not use any sign. Not any sign means only the positive numbers is going to be represented, and it is sort. Sort means it is 2 byte. So 2 byte and it is 16 bit. So the range will be, as it is unsigned, we are only using the sign, we are only using the positive number. So the range will be 0 to 65,535, right, for unsigned sort int. Similarly, for unsigned long int average, this will be 4 byte and it will be 32 bit. So 32 bit means we will only represent the positive numbers, not the negative numbers. So the range will be something like this over here. So this will be the range. Okay. Now we understand everything: signed, unsigned, sort, and long. So finally, I would like to discuss another data type which is only supported in your C99 compiler. That is a new data type supported by your C99. It will not run in your Turbo C environment. Turbo C environment does not support this particular keyword at all. It is only supported in your GCC compiler. Okay, because GCC compiler supports C99 format or C99 standard. Okay, so for long the size is actually 8 byte and the range will be something like this. You can calculate it by using your calculator. So this is the range, minus this much to plus this much. So if it is a signed long, you can use also signed long, signed long, and only long. Both are having the same, they can store, means they can display, use the same range. But if it is a unsigned, then you don't have to represent the negative numbers. That's why the range is from 0 to this much. So how did I get this number? I have added this value with this value, and this is the range. Okay, so it will take 8 byte. Now finally, that is the final table where I have represented all the, I have shown you all the types, like integer or signed integer, both are same because both used to represent positive number as well as negative number. If you are using Turbo C++ compiler, then this int will take 2 byte. If you are using other compilers, then it will be showing you 4 byte, and the range will be -32768 to +32767. For 4 byte, the range will be this much. If it is a unsigned int means you can only represent positive numbers, you don't represent negative numbers. That's why the range for Turbo C, the range will be 0 to 65,535, but for 4 byte it will be 0 to this much. If it is sort int or signed sort int, and then you will be, the storage size will be 2 byte and the range will be this much. If it is unsigned sort int, then unsigned means that you can use only positive numbers, so the range will be 0 to 65,535. If it is long int or signed long int, then you are going to use 4 bytes, so that's why this is the range. And for unsigned long int, this is the range. And the last one, which is supported by your C99 standard of C programming language, so that will be this will be 8 byte and the ranges are given over here. So I hope you understand the entire thing. That's all for the today's class, but I will try to show you how to find out these numbers. Okay, with what we will show you with a programming. Okay, so let us go for discussion of the program. Now I would like to introduce here a program that is called the size of operator. So what is a size of operator? So let's say I'm writing a program over here to know the size of each type of data type. So there is a concept called size of operator which will be used to show you the size allocated by different integers. So let us do it. So first line will be hash include stdio.h. okay, then we will write int main. So this part will be for advanced users, those who at least know some concept about C programming language. They can easily understand it. Those who don't know about C programming language and they never has written any programming language, they should ignore this part. So that thank you message, up to the thank you message, that is enough for you people. So whenever you learn about programming language, then you come and see this part. Anyway, so let us see it. Suppose I want to find out the size of integer. So how to find out? I will write like this: printf %d %d, then comma, then there is a operator called size of operator, size of. So size of, I'll write int. I want to find out the size of integer, so I'll write size of int, then semicolon. Then I have to write return 0 to complete my program. So this is my program. Now let me see how when I run this program, what will be the output. So you can see here the output will be 4. Over here it is showing output is 4 because size of integer is 4 in case of GNU compiler. Okay, GNU means your MinGW compiler. Now let me show you. If I'll make it sort int, then what will happen? Let me run it. So you can see the output will be 2 byte, means it will take 2 byte of information. Suppose I will write long int, Control S. So if I'll write long int, then the size will be, you can see 4 byte only. Okay, so if you are using the new data type which is introduced by your C99 compiler, that will be, you can see here, that is 8 byte. Okay, so I have written a complete program over here. See here. So what I have done is I have written a complete program. So the complete program is something like this: size of integer, size of int, size of signed integer, size of unsigned integer, %d size of unsigned int, then size of sort int, that is size of sort int. So I have written the complete program over here. Let's run it and see it, what is the result. So you can see, so the size is already printed over here. Size of integer is 4 byte because we are using MinGW compiler. Size of signed integer will be 4 byte. Size of unsigned integer is also 4 byte. But remember, in case of signed integer, the range will be different, and for unsigned integer the range will be different. So sort int takes 2 bytes, signed sort int, unsigned sort int, all those things take 2 bytes. Long int takes 4 byte, signed long int and unsigned long int also take 4 byte. Long takes 8 byte, and signed long take 8 byte. Unsigned long take 8 byte. Only long, signed long, unsigned long, everything will be taking 8 byte. Okay, so I am trying to combine all these concepts that we have discussed, and this is the output of this particular program. Okay, this is according to your MinGW compiler. But if you run this same program with your Turbo C++ compiler, then the size of integer will be 2 byte over here. In this particular area, it will show you 2 byte, not 4 byte. Okay, and everything, the remaining things might be same. Okay, because sort int will take 2 byte obviously, and the long int will take 4 byte. So everything will be similar as compared to, but this line will not run in Turbo C compiler because whenever we are using long int, that will not work in Turbo C++ compiler because they don't support the C99 standard. Okay, so I hope you understand the entire thing that I am discussing in this particular class. Thanks for listening. Bye bye.